Hi students, let us continue with the instruction set of 8085 microprocessor. In the previous video, I explained about the data transfer operations and the arithmetic operations. Now let us see the logical and bit manipulation operations. So the third one is logical and bit manipulation instruction operation. So for that operations, what are the operations that are present for used for logical and bit manipulation and instruction for that operation. So let's first take logically AND. If you want to perform the operation logically AND register H with accumulator. So for this, the instruction you have to write as ANAH. So ANAH means logical AND operation has to be performed. So these instructions is somewhat different when compared to the 8086 microprocessor. So the slight difference will be there for the instructions that are present in 8085 when compared to 8086. So logically OR with register L, register L with accumulator. So for that ORAL. ORA means logically OR operation has to be performed on register L with accumulator. So this is with accumulator. Next, in the same way, logically XOR register B with accumulator. So for that you have to write XRAB. So XOR, this is XOR logically with B with accumulator. Next, compare content of register C with accumulator. Compare contents of register C with accumulator. So that is CMP is compare register C with accumulator. So you have to compare the content that is present in accumulator and with the content in the register C. So both C and A has to be compared. Next, complement accumulator. So just you have to write CMA. CMA means whatever the result that is present in the accumulator, that will be complemented. Rotate accumulator left. RAL. So in the same way, rotate accumulator right all. So these are all the different logical and bit manipulation operations that are used in this 8085 microprocessor. Now let us see the next fourth one. The fourth operation is the branching operations. So what are the instructions that are present for the branching operations? Let us see. So the fourth one is branching operations. So these operations are used to control the flow of program execution. The main use of this branching is to control flow of program execution. To control the flow of program execution. So the jump instruction is used for branching. So that jump, whatever you have taken, that may be a conditional jump, means the condition is specified, or unconditional jump. Without condition also, the instruction is jump from one statement to the another statement. So a branching is used to control the flow of program execution. So it may be the branching operations may be jump or call and return. In the same way, this call and return is also maybe a condition will be there, or without condition, conditional, unconditional. So jump instruction may be conditional or unconditional. Call and return is a conditional or condition. So these two are the branching operations: jump, call and return. Now let us see the operations for this branching and the instructions that are written for this particular operation. Let me write that. Suppose I have written jump a 16-bit address 2080H is a 16-bit address if carry flag is set. So here I have mentioned a condition is mentioned here. This is a condition if carry flag is set. This you call it as a conditional jump. So whenever you are mentioned with conditional jump, you have to write C. JC means jump if condition is satisfied to 2080H. So this is the instruction for this particular operation. A jump 16-bit address H if the carry flag is set. So jump if carry. Next, let me write the unconditional jump. So the same statement, unconditional jump, means I am not mentioning the condition. If carry flag is set, I am not mentioning. So for that unconditional jump is, you have to write the instruction JMP 2080H. So this is a carry and this is unconditional jump. This is a conditional and this is unconditional. For conditional you have to use the instruction as mnemonic as JC, and for unconditional just jump. So whether if condition is satisfied or not, whenever this jump is there, you have to jump to that particular address location. Now let me write the call. Call a subroutine. Subroutine means it's just a small program or a function. Call a subroutine with its 16-bit address. Just call 3050H. Okay, so this is just calling the program, call to that particular address. Next, return back from call. So if you want to return back from that particular call, you have to just mention RET. So whenever that subroutine is over, at the end of the subroutine, just write RET. Whenever you have written this, again the program will return to that main program. Okay. So in the same way here also, if this is both are unconditional. Unconditional. Suppose if you want to mention any condition like, let me write, call a subroutine. Let me take in the pen. Call a subroutine with its 16-bit address if carry flag is set. So here I am mentioning the condition. So whenever you mention the condition, you call it as a conditional jump. So further the instruction is CNC. Okay, so call a subroutine whenever the carry flag is set. 3050H. So if it is unconditional, you have to write the syntax as call. If it is condition is there, you have to write CNC. CNC. In the same way, for return also a conditional will be there. Return if 0 flag is set. So further the instruction is RZ. So simply unconditional jump means just RET. So whenever the condition is specified, you have to write RZ. If return if 0 flag is set, RZ. So this is about the branching operations. Jump, conditional, unconditional, call and return, conditional and unconditional. Now let us see the last instruction set, that is stack, input, output and machine control operations. So everyone knows the stack operations are push, pop, SPHL means move the content of H and L to the stack pointer. SP is the stack pointer. So whatever the content that is present in H and L register, that will be moved to the stack pointer. Okay, and so on. And coming to the IO instructions. So IO instructions are nothing but in, out. Okay, so in is used to initiate, input port is initiated. Out means output port will be initiated. And coming to machine control instructions, these instructions are used to control the machines like EI. EI is nothing but, it's saying interrupt is enable. Enable interrupt system. means it is controlling the machine by saying interrupt is enable. DIE, disable interrupt system. HLT, this is halt the operation. NOP, no operation. So these are the different stack, input, output and machine control operations that are used in 8085 instruction set. Thank you.